A powerful magnitude 6.1 earthquake just struck near Vanuatu. And while the shaking was strong enough to register clearly on seismographs around the world, the story behind why this specific quake likely caused little to no damage tells you a lot about how earthquake risk actually works. So let's get right into exactly what happened, where and why depth matters just as much as magnitude when it comes to understanding real-world impact. Let's start with the hard numbers, because they come directly from the United States Geological Survey and multiple independent seismic monitoring agencies that all recorded this event in close agreement with each other. The earthquake struck at 3:20 in the morning, Coordinated Universal Time, on August 16th, with its epicenter located 56 kilometers, about 35 miles north-northeast of the small coastal village of Port Olry in Vanuatu's Sanma province. The quake registered at magnitude 6.1, confirmed independently by both USGS and the European Mediterranean Seismological Center, which reported the same magnitude and depth, a level of cross-agency agreement that gives seismologists real confidence in the accuracy of these initial readings. Here is the detail that matters most for understanding why this earthquake likely did not produce significant damage, despite its considerable magnitude. USGS recorded the quake's depth at 188.1 kilometers, nearly 117 miles beneath the surface, classifying it as an intermediate depth earthquake. That depth is genuinely significant, and it is worth explaining exactly why. Earthquake damage at the surface depends heavily on how much of the released energy actually reaches ground level with meaningful force, and that energy naturally disperses and weakens considerably as it travels upward through many miles of solid rock. A shallow earthquake, occurring just a few kilometers beneath the surface, delivers its energy to the surface with far less material to travel through, and absorb that force along the way. An earthquake occurring nearly 188 kilometers down, by contrast, has that same released energy spread out and weakened across a vastly greater distance before it ever reaches anyone standing at the surface, which is precisely why a magnitude 6.1 earthquake at this depth registered as only light shaking, rated at modified Mercalli intensity 3.9 in the one felt report USGS received following the event. According to detailed technical analysis of this specific earthquake, the total seismic energy released was equivalent to roughly 21 kilotons of TNT. And using standard empirical fault scaling relationships developed by seismologists Wells and Coppersmith back in 1994, researchers estimate the actual subsurface rupture. Length involved was approximately 9.7 kilometers, giving a useful sense of scale for exactly how much of the fault actually slipped during this specific event. USGS's automated pager system, which rapidly estimates likely casualties and economic impact immediately following any significant earthquake, worldwide assigned this event a green alert level, its lowest category, specifically indicating that no significant casualties or damage were expected as a result of this quake. Consistent with that assessment, Vanuatu's own Natural Hazards Department did not issue any tsunami warning following the earthquake, and there were no early reports of any damage from the affected region. Let's talk about why Vanuatu experiences earthquakes of this kind so frequently in the first place, since understanding the underlying geology explains why this event, while genuinely significant in magnitude, represents fairly routine activity for this specific part of the world. Vanuatu is a low-lying archipelago nation stretching across the South Pacific, sitting directly along the Pacific Ring of Fire, the roughly 25,000-mile arc of intense seismic and volcanic activity that circles the entire Pacific Ocean basin. This positioning places Vanuatu at the boundary where the Australian plate is being forced beneath the Pacific plate, a subduction zone configuration capable of producing frequent, sometimes quite powerful earthquakes as accumulated tectonic stress along that boundary periodically releases. According to earthquake tracking data specifically compiled for this region, Vanuatu experiences a genuinely substantial amount of seismic activity on an ongoing basis, with 143 recorded earthquakes across the past full year alone, an average pace that works out to roughly one significant earthquake every 2 to 3 days somewhere across the broader region. Within just the past week surrounding this specific event, 6 separate earthquakes were recorded, and within the past 30 days, 18 total earthquakes struck the region. This kind of frequent seismic activity is simply the ordinary, expected baseline for a nation sitting directly astride an active subduction zone boundary, rather than representing any kind of unusual spike or emerging concern specific to this particular week. It is worth placing this magnitude 6.1 event within the broader historical context of what Vanuatu's fault systems are actually capable of producing at their most extreme. According to historical earthquake records for the region, the largest earthquake ever recorded in Vanuatu reached magnitude 7.9, a considerably more powerful event representing an entirely different scale of potential seismic hazard compared with this week's magnitude 6.1 earthquake. Even within just the current calendar year, the region's largest recorded earthquake reached magnitude 7.3, striking near Luganville, also within Sanma province, illustrating that this broader region remains capable of producing considerably stronger events than the one that just occurred near Port Olry, even during what would otherwise be considered a fairly typical year of seismic activity for this part of the Pacific. This earthquake also arrived within a broader regional context worth understanding, since Vanuatu's seismic activity this week followed closely on the heels of a considerably more devastating earthquake elsewhere in the same general Pacific region. Just one day before this magnitude, 6.1 event struck near Vanuatu. A magnitude 7.7 earthquake struck Indonesia, killing dozens of people and triggering hundreds of subsequent aftershocks. While these two earthquakes are not directly connected to each other in any physical sense, given the considerable distance separating Indonesia from Vanuatu and the fact that both nations sit along entirely separate, though broadly related, sections of the wider Pacific Ring of Fire, their close timing offers a useful illustration of just how consistently active this entire Pacific tectonic boundary system remains, with significant earthquakes striking somewhere along its enormous length on a near constant basis. Let's talk about why USGS and other monitoring agencies continue tracking and publicly reporting on earthquakes like this one, even when the immediate pager assessment indicates minimal expected damage or casualties. Every earthquake, regardless of how much surface damage it ultimately produces, adds valuable data to the broader scientific understanding of exactly how a specific fault system or subduction zone behaves over time. Intermediate depth earthquakes like this one, occurring within the descending slab of the subducting Australian plate itself, rather than along the shallower boundary where the two plates directly meet, provide seismologists with important information about stress conditions occurring considerably deeper within the subduction system than shallow earthquakes alone can reveal. That deeper insight genuinely matters for building more complete, more accurate models of how this entire fault system behaves across its full depth range, not just at the shallow boundary where earthquakes tend to pose the most direct surface hazard. It is also worth understanding how aftershock sequences typically unfold following an earthquake of this specific magnitude, since that context helps set realistic expectations for what residents across the affected region might experience in the days and weeks ahead. According to standard seismological monitoring practice, aftershock sequences from a magnitude 6.1 earthquake can continue for weeks to months following the initial event, though the frequency and magnitude of these aftershocks typically diminish gradually over time rather than continuing at anything close to the intensity of the original quake. USGS continues monitoring this specific region closely for exactly this kind of continued activity, standard practice following any earthquake of significant magnitude, regardless of how much immediate surface damage the initial event actually produced. So what should residents of Vanuatu and the broader South Pacific region actually take away from an earthquake like this one? First, understand that Vanuatu's frequent seismic activity is simply the ordinary, expected reality of living directly along one of the world's most active subduction zone boundaries, and that a green pager alert following an earthquake like this one genuinely does reflect a low likelihood of Second, understand that depth matters just as much as magnitude when assessing how dangerous any specific earthquake is actually likely to be, since this same magnitude, 6.1 energy release, had it occurred at a shallow depth close to the surface rather than nearly 188 kilometers down, would likely have produced considerably more significant shaking and a correspondingly higher risk of real damage. And third, understand that ongoing earthquake preparedness remains genuinely worthwhile for anyone living across this broader region, regardless of how any single specific event turns out, given the well-documented historical capability of the same fault system to produce considerably more powerful earthquakes, including the magnitude 7.9 event that stands as the largest ever recorded in Vanuatu's history. It helps to understand a bit more about why intermediate depth earthquakes like this one occur at all, since the mechanism differs meaningfully from the shallow earthquakes most people are more familiar with. As the Australian plate subducts beneath the Pacific plate along the stretch of the Ring of Fire, it does not simply disappear once it dips beneath the surface. It continues descending as a coherent slab of relatively cold, dense rock, sinking gradually deeper into the mantle over millions of years. As that descending slab travels deeper, it experiences enormous changes in pressure and temperature, and the rock within it undergoes genuine physical and mineralogical transformations as it adjusts to those changing conditions. These transformations can themselves generate significant internal stress within the descending slab. entirely separate from the stress generated at the shallower boundary where the two plates initially meet, and when that internal stress within the deeper slab exceeds what the surrounding rock can withstand, it produces exactly this kind of intermediate depth earthquake, occurring well within the body of the subducting plate itself rather than at the shallower interface between the two plates. This distinction matters because intermediate and deep earthquakes, generally classified as occurring anywhere from 70 to 700 kilometers below the surface, actually make up a meaningful share of global seismic activity, even though they receive considerably less public attention than shallow earthquakes do. That reduced attention makes sense given what we have already covered, since the same magnitude event occurring at depth simply poses far less direct surface hazard than an equivalent shallow earthquake would. But from a pure earthquake science perspective, these deeper events remain genuinely important for understanding the complete three-dimensional structure and behavior of a subduction zone, since they reveal information about stress conditions occurring well beneath the shallow boundary that dominates most public earthquake hazard conversations and emergency planning efforts. It is also worth understanding Vanuatu's broader vulnerability profile beyond just its seismic activity, since that context helps explain why earthquake monitoring across this specific region receives such consistent attention from international disaster response organizations despite the nation's relatively small population. Vanuatu is frequently ranked among the world's most disaster-prone countries when measured against its population and economic size, given its exposure to not just frequent earthquakes, but also active volcanoes, tropical cyclones, and rising sea levels tied to its low-lying island geography. That combination of overlapping natural hazards means international monitoring agencies and regional disaster response networks maintain especially close, continuous attention on any seismic activity in this specific part of the Pacific, since a genuinely damaging shallow earthquake, unlike this week's deeper, less impactful event, could compound quickly with the nation's existing vulnerabilities in ways that considerably larger, more resourced nations might be better positioned to absorb and recover from. Let's bring this all together. A magnitude 6.1 earthquake struck 56 kilometers northeast of Port Olry, Vanuatu on August 16th, confirmed independently by both USGS and the European Mediterranean Seismological Center. Despite its considerable magnitude, the earthquake's intermediate depth of nearly 188 kilometers meant the energy reaching the surface arrived considerably weakened, producing only light shaking, no tsunami warning, and no early reports of damage reflected in USGS's automated green pager alert, indicating minimal expected impact. This event represents fairly routine seismic activity for Vanuatu, a nation sitting directly along the Pacific Ring of Fire that has recorded 143 earthquakes over just the past year alone. Though the region's historical record, including a magnitude 7.9 earthquake, standing as its largest ever recorded event, is a clear reminder that this same fault system remains capable of producing considerably more powerful and potentially damaging earthquakes than the one that struck this week. I will keep tracking seismic activity across Vanuatu and the broader Pacific Ring of Fire closely, so make sure you are subscribed to the channel and have notifications turned on for whenever there is a significant new earthquake worth covering. It is also worth understanding how the pager system specifically arrives at its rapid impact assessments, since this automated tool plays such a central role in how earthquakes like this one get initially characterized to the public within minutes of occurring. PAGER stands for Prompt Assessment of Global Earthquakes for Response, and it works by combining an earthquake's magnitude and depth with detailed population data for the surrounding region, along with estimates of local building construction, quality, and vulnerability, to rapidly generate a probabilistic estimate of likely casualties and economic losses. A green alert, the lowest of PAGER's 4 color-coded severity levels, specifically indicates that estimated fatalities and losses are expected to fall within a range considered minimal, typically 0 to a small handful of casualties at most, based on the specific combination of magnitude, depth, and local population exposure involved. This automated system allows international disaster response agencies and news organizations alike to quickly gauge, within minutes of any earthquake occurring anywhere in the world, roughly how seriously that specific event is likely to need urgent humanitarian attention without needing to wait. For the kind of detailed on-the-ground damage reports that can take considerably longer to actually compile and verify following a major event. There is also genuine value in understanding how this specific earthquake fits into the broader pattern of monitoring that spans the entire Pacific Basin simultaneously, rather than treating any single national seismic network as operating in isolation. Agencies like USGS maintain continuous, real-time monitoring across the entire Pacific Ring of Fire, tracking seismic activity across dozens of countries and territories at once, from Vanuatu and the broader South Pacific through Indonesia, the Philippines, Japan, and up through the Americas. That comprehensive, basin-wide monitoring approach is precisely what allows scientists to place any single earthquake, including this week's event near Port Olry, within its proper regional and historical context so quickly, drawing on decades of accumulated data about how each specific stretch of this enormous tectonic boundary has behaved in the past, and using that historical baseline to help calibrate expectations for what any new earthquake is actually likely to mean for the people living nearest to it. Thank you all so much for watching today's video. Even a magnitude 6 earthquake does not automatically mean disaster, and understanding exactly why is one of the more genuinely useful things anyone living along an active fault system can learn. I will see you in the next one. If you live anywhere across the South Pacific, or simply want to stay informed about seismic activity in this consistently active region, official sources like the USGS earthquake feed and Vanuatu's own National Disaster Management Office provide the most reliable real-time updates available, considerably more dependable than secondhand social media reports that can sometimes exaggerate or misrepresent an event's actual severity before. Official assessments are complete. Building that habit of checking primary, official sources first is a genuinely useful practice for anyone living along any active seismic zone, not just Vanuatu specifically, since it ensures you are making decisions based on verified data rather than the kind of understandable but often inaccurate initial panic that can spread quickly in the minutes immediately following any earthquake, regardless of how minor its ultimate impact actually turns out to be once the full picture becomes clear.